30 years, yeah. All right, so you obviously know, but he wasn't planted. So this is actually the founder of our company, Chuck Hall. He invented stereolithography 30 years ago. He recently won the Inventors Hall of Fame award granted by the U.S. Patent and Trade Office. And that's actually the first artifact ever manufactured. He was moonlighting at the time. He had a storied history in the material science industry, worked for DuPont and a few other companies. And his lab said, yeah, sure, you can work on your own little experiments at night. We don't mind. So he was doing this at night. He was actually working on designing, using CAD, simple structures, and experimenting and iterating on how best to photopolymerize a structure into actual real, so converting the digital into the physical. And the way he tells it, it took several tries, but one night around, I think he said it was 10 o'clock, he called his wife and, said she needed to come down to the lab and check it out. He wouldn't explain what it was, but this is the eye cup that he printed. And I actually had an opportunity to see the first SLA, first stereolithography machine that was ever sold. Does anyone have any idea what industry and what company would have bought the first 3D printer? Any guesses? No?
We have a guess.
What's that? No? Come on, guess. Any guess? What? So the first company to ever make close, MakerBot wasn't even born yet. So the first company to ever buy a 3D printer was General Motors. And so I saw it was called SLA3, and it had one of these, a lot of people, well, there's some people who are my age and older. So you may recall the TRS-80s or the Commodore 64 type computers. So it's basically, it's still in operation there, actually. but they had hooked up a 64K computer to this amazing machine, and it was being used for rapid prototyping, and wind tunnel testing. And it's remarkable. So when folks start talking about 3D printing and talking about the future and how we are on the cusp of something great, I'd like to remind folks that, sure, the future is grand and there's a lot of innovation to be had, but we're also in need of continual focus. We need to be vigilant on and focus on innovating new technologies in this space. We need to make sure we're not resting on our laurels. And when folks suggest that the U.S. is leading the way here, Ed is very eloquent on this fact. That's actually not exactly true. Actually, I would say, as Ed was alluding to the Asians, I would also say the Europeans are really beating the crap out of a lot of other companies, particularly in the metal powder bed space. And we're doing a little better now, and I'll get into that in a second. And a lot, I think, has to do with the kinds of work that Ed and his colleagues are doing at America Makes. So this is just to highlight some of the verticals that, and speaking of eye charts, this is to highlight some of the verticals that we play in, some of the principal verticals, so aerospace, healthcare, and automotive. I wanted to also, this is a video, oh, look at that, it's working. So this is a company, a little company in Oregon that makes footwear. So this is actually, Nike has been using stereolithography as well as binder jet and now selective laser sintering. And the selective laser sintering that was illustrated there, they're actually customizing the soles for high performance athletic gear. And it's kind of an exciting new future that we're seeing in customized wearables. This sort of discusses a little bit more about what we're trying to get at when we talk about additive manufacturing. One of the things that really is a pet peeve of mine is when folks leverage 3D printing to basically replicate what's already being made through conventional means. As Ed said, additive manufacturing is not an ends to a mean, it's a means to an end. It's just one tool in the toolkit. What's exciting about 3D printing is you can make things through this process you just can't make through any other way. And so that's kind of our mantra in the industry. Ed already went through this, so I'm not going to cover that much. Here's more illustrations. We all have, I think, a lot of different examples. I'm actually a guest researcher at the U.S. Army Research Lab, where they have a very extensive laboratory. And I brought a couple of specific applications that the Army has been using for some years now in additive manufacturing. Healthcare actually followed soon after the automotive industry. Are folks familiar with Invisalign? Anyone know what Invisalign is? So Invisalign uses, I think they make 20 million individual 3D prints every year. And you just think about that. So there's, this was actually a really exciting story. Two graduate students from Stanford approached Chuck Hull, my current boss, and said, we have a great idea to make things wireless. Wireless meant different things back then. And we worked with them and set up this incredible venture which has just exploded. Another example is hearing aids. Can anyone guess the percentage of hearing aids that are 3D printed in the world? Another guess. 99.5% of all hearing aids are 3D printed. So again, when folks are talking about the future is now, you know, we should be a little more grounded. And the reason why I want to say that is this is a mainstream technology. It's really important that people appreciate that we can't wait. We need to keep staying ahead. That actually, I think when we were testifying before Congress, oh, this thing's not working anymore. We were testifying before Congress last week or 2 weeks ago. This thing's not working, by the way. So,
Annual override.
Oh, there you go. I think people were kind of surprised by that fact that they had no idea that. So I broke the system. So I'll just keep moving on. If we get the pictures, great. The next slide actually illustrates another very exciting application in the field of healthcare. Is this thing working again? Yeah, mine's not working, so, yeah, one more, or one more. Oh, there you go. Okay, that's good. So this is a first responder, Patrick Hardison. He was gravely injured in the line of duty as a volunteer firefighter in Senatobia, Mississippi in September 2001. He entered a burning home on a rescue search, and the roof collapsed, and it left Patrick with traumatic and disfiguring injuries to his head, neck, and upper torso. What we were able to do in this particular case was use both a process called virtual surgical planning as well as medical modeling. One of the things that I've learned recently is that it costs about $100 a minute in the operating room, typically, for traumatic surgeries. And so if you can reduce the amount of improvisation to zero and actually have surgeons rehearse way before the operation takes place, you're not only going to have a surgeon who knows what the heck he's doing, you're also going to save a lot of money for the patient. And so in this particular case, you can take scans, 3D scan the face. They can practice on models, but also they're able to make, with biocompatible materials, surgical guides, which are basically stencils. So they can actually put the stencils on the patient's face and actually guide their surgical processes. And it's a remarkable process. It's being used in tens of thousands of cases, and it's very important that we continue to push the envelope again and innovating here. Next slide. And this sort of illustrates some of the other applications. We're actually, 3D Systems, the only major U.S. 3D printing company in the world, and we're, I think, the only FDA certified facility for class 1, 2, and 3 devices, and we're mass producing everything from implants to other medical devices. Next slide. I'm not going to get into these too much. This is just sort of a sheet of some of the, and you can't really see it anyway, but this is just an illustration of some of the government research we've been doing. A lot of them are in concert with America Makes, and the work that America Makes has actually catalyzed is helping us insource a lot of work, both for my own company as well as for other companies in the United States. And so we're really proud of our membership with America Makes. It's a very important institution. Next slide. I'm just sort of ticking through a couple of aerospace applications. We talked about medical. The Joint Strike Fighter, correct me if I'm wrong, you said there was it 5,000?
Over 5,000.
Over 5,000 components of the Joint Strike Fighter are made via 3D printing.
So, if I may, the Joint Strike Fighter is made with over 5,000 3D printed tools. The tools to make the aircraft and do the assembly.
So there's actually a cost-benefit analysis that's been done to sort of indicate how best to consolidate that supply chain. We've actually been working with the Air Force and others on how to manufacture directly some parts using high-temperature polymers, and this sort of illustrates some of the places where that is useful. This is a really exciting story of a company called Planetary Resources. A typical NASA space vehicle weighs hundreds of pounds and costs hundreds of millions per copy, and it's made with over 1,000 moving parts. But thanks to 3D printing, a space exploration startup plans to launch their first spacecraft are happening this year, and this craft weighs less than 20 pounds and costs only a couple of millions per copy and is made with less than 20 moving parts. So it's just another great illustration of what we're doing in this industry. Next slide. I'm going to get off the stage here. I talked a little bit about the automotive industry as one of the first users of this industry. It began in the rapid prototyping space. It's moved on into the wind tunnel testing and in the tooling arena, and now we're seeing a lot of direct production parts. Formula One in particular has been a very active user of 3D printing, particularly because of the efficiencies you can get through the free complexity that we're bringing to the table. And the next slide just sort of brings together a couple of logos that you can find on Google, but basically any major company you can think of in the manufacturing space is using 3D printing in one shape or another. And some, such as GE, are incredible leaders and really pushing companies like us to push the envelope further. We are seeing a push and pull, both from the demand side as well as hopefully from some of the great ideas that are coming out of our labs. And so we're really eager every time we can to take advantage of those partnerships. And America Makes is a really great incubator for those kinds of relationships, and you see more and more exciting partnerships pop up every day. Last slide, I think, is my contact information. So with that, I'll look forward to taking your questions. Thank you.